Hi everyone, welcome back. The problem for today is number complement. So it is a LeetCode problem and it is also posted on May LeetCode challenge. The problem is given a positive integer, output its complement number. The complement strategy is to flip the bits of its binary representation. Let's understand it with example. Suppose our input is 5 and its binary representation will be 1, 0, 1. If I flip all its bits, it will become 0, 1, 0, and in decimal form it will be 2. So if our input is 5, our output should be 2. Let's take one more example, 6. Then the binary representation of this will be 1, 1, 0. If I flip all its bits, it will become 0, 0, 1, and in decimal form it will be 1. Okay, so before getting to the solution of the problem, just try to revise the concept of XOR. So according to XOR, if two inputs are same, then their output will be 0. Like if zeros or 0 is 0 and ones or 1 is 0. If two inputs are different, that is zeros or 1 or ones or 0, then output will be 1. So that is what the concept of XOR is. One more thing, if we XOR anything with 1, suppose if I XOR 0 with 1, it will be 1. If I XOR 1 with 1, it will become 0. Basically, if this is our input, then output will be its flipped version. Similarly, for if I XOR anything with 0, it will remain same. Like if I XOR 1 with 0, it will output same. So if we XOR anything with 1, it will invert it. If we XOR anything with 0, it will remain same. Okay, let's move on to the solution of our problem. Okay, let's take the same example as number is equal to 5 and its binary representation will be 101, and we will take one more variable, that is output, and we initialize it with the same as our input, that is 5, and its binary representation also will also be same, that is 101. Now what we will do, first of all, we will flip the first bit from the right side, then second bit from the right side, and then third bit, and so on. So how to flip the first bit? Simply, as we have covered the topic of XOR, we will simply XOR it with 1. So only first bit we are XORing with 1 and all other bits we are XORing with 0, because on XORing with 0 the input will not change. Only the first bit will change. So here we can also keep track which bit to flip. Let's say position is equal to 0 represent the first position. So to get this number, simply we can write 1 shifted by position. So if we write 1 shifted by 0, this will be our output. And if we XOR, it, then it will flip this bit only. So it will be 1, 0, 0. Again, we increment the value of position, that is 1. We will XOR it again. So to get the value of flipping bit, it will be 1 shifted by position. Now position is 1, then it should be 0, 1, 0. So when we XOR it again, it will be zeros or 0 is 0, zeros or 1 is 1, and ones or 0 is 1. So basically it flip only this bit, all other bits are same. And again we will do it for position is equal to 2. So when we do it position is equal to 2, so we will write 1 shifted by position, and here the bit will be 1, 0, 0, and our output will be, it will flip this bit only. So this bit will become 0, all other will remain same. So it will be 0, 1, 0. Our output should be 0, 1, 0. So we already got our output. But the problem is, in memory, if we want to store 5 in 4-bit representation, it will be represented as 0, 1, 0, 1, not as 101 only. So there will be 10 appended on the left hand side. And if we flip all the bits, the output will become 1010, and that will be wrong. We want to flip the bits up to the leftmost one of the most significant one, that up to here only we want to flip the digits. Before this, whatever the 0 are available, we don't want to change them. For that, what we can do, we can check if there is anything left on the left hand side of that bit. Suppose when we are doing here 0101, first of all we flip this bit. If somehow we can check if there is any 1 on the left hand side, then we will continue. If not, then we will stop. Here also again we are flipping this bit. If somehow we can check if there is any 1 left on the left hand side of this 0, then we will continue, else we will stop. Again, here also we are flipping this bit. If there is any one left on the left side, then we will stop. Yes, here we should stop, but how can we check it? For that, what we can do, we can just simply shift our number. Like our number is num, and if we shift it by position, so here the position value is 0. After shifting, right shifting it by 0, it will remain same, that is 010, and its decimal representation will be 5. When position is equal to 1, when we have to flip, so when we have to flip the bit at first position, first we will check the value of num right shifted by one time. That will be 0010, and its decimal representation will be 2. Again, we will do the same thing here. Num shifted by position, and when we shift it by 2 times, it will become 0001. So it is non-zero 1. So we will flip the second bit also. Now we will continue. For position is equal to 3. First of all, we will check the same value. So when we shift 5 by 3, it will become 0000, and the decimal value is 0. The moment the decimal value becomes 0, it means there is nothing on the left hand side of this bit. So we will stop. We will not flip the third bit. So that is the whole algorithm. Now let's see how we can code this. The code will be very simple. Like first of all, we are given a number, let's say 5. We will take one more variable in which we will store our output, and we will equate it equal to num. We will create one more variable to keep track of the bit which we want to flip, and it will run till the right shifting of our number by this position is non-zero. So first operation is simple. We will XOR output. We will XOR output with itself and one shifted by position, and each time we will just increment the position value to 1, and at the end of the loop we will simply print our output, or we can return it if it is a function. So this is a very simple code for that. So what I am trying is I am trying to write as generic solution as possible, so that the same solution can be run in C++, Python, and other language also. So that is all for today, and thanks for watching.